Okay, we quickly explain our development of an intelligent camera for elderly's full risk assessment. Okay, for more details, you might search our the publication from our group, me with my PhD student and postdoctoral fellow. Okay, okay. Suppose here is an example we took from YouTube. It is example of the 3 seconds sit to stand. Okay, then we use this example. We use this as example. Okay, okay, because the the image analysis we develop now can recognize multiple people. So of course we still recommend, okay, if the elderly can perform the test by himself, then better just shoot one person. But in case their assistants sit in be next to the elderly, our intelligent camera can still recognize it. Okay, now uh, we use DeepSort and KeypointsRCNN to extract the the joints and the the subject ID. Of course, if you have if you can run the program at your own computer, okay, with inside Anaconda, then you just run it. Suppose you want to test the technology and you don't have Anaconda installation on your computer, or you don't have GPU access, you can still test or run and test. So first you go to my GitHub. Okay, you go to my GitHub and then go to this intelligent camera. Okay, and then you open this DeepSort and the key points. Okay, the first program is for Anaconda. Okay, for this one. Okay, once you open it, okay, it's very nice. You can open my program in Colab directly. So just click this open in Colab. Then you can open my program in Colab. Okay, of course you have to log in to Google first. Okay, once you log in, okay, you go to this and you can change the okay the is GPU setting to GPU. Okay, so Google is very nice. Okay, this Colab cloud platform allows you to run the neural network applications in cloud without any installation on your own computer. It's very convenient. So let's run this first. Okay, and it will say, okay, it will detect it's connecting to Google and initialize. Okay, once it initialize, it will run. See, in this time, Google give me Telsa T4 GPU. Okay, then of course you have to put the DeepSort PyTorch zip file I gave you. Okay, suppose you put this just in your Google Drive, then you can connect from Colab to your Google. Okay, so just copy this authorization link and paste here, hit enter, then you will connect from Colab to your own Google Drive. Okay, now we are going to unzip. So just put this zip file in your Google Drive. Don't unzip it. We will unzip inside the Colab program. Of course, if you run your own program in Anaconda, then it's okay. But here I assume you don't have any Python installation on your computer and you still want to try. Okay, and then we just set the configuration file and the load. Okay, here I just let it load, so I'm going to pause for a while. Okay, now I already load the DeepSort neural network. Now I'm going to load the KeypointsRCNN for joint detection. Okay, now I'm going to upload this file from my local drive. It's in desktop, PyTorch. Okay. It takes a while to upload. Okay, it takes like 2 to 3 minutes to upload this 3 seconds of video to Colab. Okay, you might click this file and go to this DeepSort folder. You might check, okay, the file is already uploaded from your computer to the Colab platform. Now I'm going to take a look at the file. Okay, I'm going to take a look at the first 10 frame. Okay, make sure, see, I already upload the file to my Colab. Okay, then I'm going to run DeepSort and KeypointsRCNN to analyze it. Okay, as you can see. Well, here as you can see, the DeepSort program we implement, we got from the DeepSort program we got from PayZQ's GitHub still have some bug. Okay, so you just run, see the label keep exchange. Okay, originally the subject is number 1, but as you can see in some frame, this subject, the label will switch. Okay, at this moment you just try and just let me know when, okay, the label will change. I need to figure out how to fix this bug. Okay, as you can see, now change to label 1. So if possible, although the DeepSort can let us track the subject ID, the program we download from PayZQ's DeepSort, I think is not very stable. So if possible, just your video just have 1 subject. Okay, if this elderly needs some assistance people stand behind to take care. Okay, well, we hope that DeepSort can help us identify the subjects. Here, as you can see, what it keeps change again. Okay, so I'm going to pause for a while to let it finish. Okay, it takes about 3 to 4 minutes for the DeepSort and PyTorch KeypointsRCNN to extract data. Now we want to save the data to CSV file, so just keep running. Okay, once we finish, go to here, go to the DeepSort folder. You can see this result. Okay, it's the result video as together with 2 CSV files. Let's download them first. Okay, we download from Colab to our own computer and start to analyze the data. Okay, let's take a look at the download data first. This is the okay. So as you can see, the DeepSort program is not stable. Okay, the subject identified keep change. Okay, at this moment just record. Okay, I will try to fix this bug. Okay, and this is the data from DeepSort. Okay, the frame and ID number, and this is the data from the KeypointsRCNN to recognize the joints. This file is pretty large because 30 seconds, Okay, so frame number, subject ID, and the 17 joints. Okay, so before we do quantitative analysis, I always recommend to visualize it. Okay, I recommend to use Tableau Public, which is free and very easy to use. And because our data is in CSV, so we just choose text file and go to download. For example, I take a look at. Okay, here as you can see, the Tableau import the CSV file, the KeypointsRCNN results, frame number, subject ID, x1, blah blah. Okay, go to this and we want to take a look. For example, I want to take a look at different, for example, the x1. Okay, remember, go to uncheck this aggregate measure because now we have two subjects, so we put the subject in different color. Also, I want to put this, okay, and show the subject as a filter. Okay, now suppose I want to take a look number 1 or number 2. Okay, so always recommend to use Tableau to quickly take a look at your data. Now, if you want to do further analysis, that's done in our paper. For example, calculate the mean square, the multi-scale entropy, or calculate the time frequency, the image. You can also go to my GitHub. Similarly, go to this intelligent camera and, for example, open this MSE. And now it's very convenient. You just click. Then you can open my program in Colab and directly run my program. Okay, now we select. For example, I select the key points. Okay. Now get the file name using pandas to read. Okay, show the first 3 rows. Maybe we take a look. First 3. It's frame number 3 SID X1. Okay, if you might check this by yourself. Show all the columns, and we want to take a look at subject 1 or subject 2 or all of them. Okay, in this example, I want to analyze the X1. Okay, time series. You calculate the multi-scale entropy of the subject ID 1 and the X1. So I'm going to subject ID. So extract all the subject ID 1's data. Okay. Now I want to get, oh, here I use X2. Okay, it's okay. Let's go to X2. We simply drag X2 here. It looks similar. Okay, so if you don't want X1, just drag it to any empty place here. Okay, now we take a look. We calculate the multi-scale entropy of X2. Okay, and convert to NumPy. So the total data number is 478. You might check in Excel by yourself. Now we install the Python entropy module because we want to calculate multi-scale entropy or the permutation entropy, blah blah. Okay, so we import and then we calculate and we plot. So that's the multi-scale entropy at scale 1, 2, 3, 4. Okay. Okay. If you want to go further analysis, you can go to my GitHub. Still choose and open this. Okay, if you want to run the time frequency picture shown in our Shihai's paper, okay, you can go here and similarly open in Colab. Okay, similarly load our data. And okay, use pandas to read the data, show the first three, show the columns, select user ID, okay, show the first three rows of user ID 3, ID 1, sorry, and select, oh, here we also select S2, it's okay. Convert to NumPy and load the Python wavelet transform module and calculate. Okay, for more details, I will ask Jiaxuan, Shihai, or Qihan to explain in our meeting. I will skip the details here. Here, I just show you how to run it. Okay, now once we run it, we see the original time series as well as the 2D image of the time frequency picture. So it will shows you the same time scale and the different frequency scales of the energy, okay, or the strength. Or we might try using Y, for example, Y5. Okay, maybe go here. Let me drag Y5. So Tableau is very convenient. I recommend you to open both my GitHub Python program as well as Tableau during your data analysis. Maybe okay, let me change this to line. Okay, as you can see, okay, that's okay, and that's the time frequency. Okay, for more details, you might refer to our publication. Okay, or I will ask Shihai and Qihan and Jiaxuan to explain these details just later. Okay.